In this video, we're going to look at exact values of trig ratios. Now, this is important because we use angles such as 30 degrees, 45 degrees, 60 degrees, and 90 degrees quite a lot. And it's good to know what those values are, what the ratios of those values are, without having to go to your calculator every time. Okay, so if you can write down your sine, cos, and tan for those values without having to use your calculator, that's really, really handy, and it also gives you a feel for what values should be if you're just sort of around there, so you can estimate, and just gives you that sort of sense of what your answer should be without actually having to calculate it. These turn up all the time in non-calc sections of exams, so that's another reason to really get your heads around this. Okay, so just quickly, with conventions of exact values, because when we're talking about exact values and ratios, we're talking about surds, so square roots. So the convention with surds is that when you're writing fractions, you're writing them with rational denominators. So of course, a surd is irrational. So a rational denominator means that you don't have a surd on the bottom. Okay, so the way you get rid of that, to rationalize the denominator, you just multiply by whatever that surd is, because of course root 3 over root 3 is just 1. Okay, so when you multiply that across, you get root 3 on, and of course when you multiply that, root 3 times root 3 is just 3. Okay, so 1 on root 3 is the same as root 3 on 3. So generally we like to write with rational denominators. Having said that, when you're talking about exact values of sine, cos, and tan, often you do have a root 2 or root 3 on the bottom. They're a little bit more recognisable sometimes, so don't get too concerned. But if in doubt, then rationalise the denominator. You're never going to lose marks for rationalising it, but you might if you don't. Okay, so yeah, just make sure that you're doing that. Also, that might mean that if you forget to rationalise the denominator when you're doing exercises in the book, the answers at the back might be slightly different if they have rationalised the denominator, so that could explain why you're getting different answers. Okay, so let's have a look here. Imagine we've got this triangle. This is an equilateral triangle. Okay, and we're going to say that the side lengths are 2. Okay, so each of these is 60, 60, and 60. So we know that. 60, 60, and 60. Now, in order to look at sine, cos, and tan, we really want a right angle triangle. Okay, so if I bisect this angle up here, so draw that, make that a right angle triangle. Okay, so what I've got now is a triangle that looks like this. We just consider one side of it. We know that's 2. Okay, if I've bisected it, we know that this length is now 1. This stays at 60. Okay, and this is now 30. So 30 and 60 are quite common angles when we want to think about that. So we need to work out what this side length is here. Now, using Pythagoras, we can say, well, the square of that is 4, minus the square of that is 1. So the square of that is 1, so 4 minus 1 is 3. Take the square root, so this has to be the square root of 3. Okay? This is called our 1, 2, root 3 triangle. And if you can remember that, just what this looks like, then you can always work out your sine, cos, and tan ratios. Okay, because we can just use SOHCAHTOA on that, which we'll come to in just a minute. So just make sure that you're happy with where that triangle comes from. Remember, the 1 is opposite the 30, the root 3 is opposite the 60, okay, and the 2 is on the hypotenuse. If you can get those right, 1, 2, root 3, and reproduce this, then you'll never have any trouble remembering your exact values. Similarly, we can do the same thing for a 45-degree triangle. Now, if these are both 45, then clearly it's isosceles. Okay, we're going to say that's 1 and 1. Just arbitrarily designate that as 1 and 1. Now, if those two are 1, that means the hypotenuse must be square root of 2. So this is our 1, 1, root 2 triangle. Okay, so if you remember 1, 2, root 3 and 1, 1, root 2, that's all you need to know in order to remember your exact values. Okay, so how do we use these? Well, if we flick over, whoops, come back to that. If we flick over to these slides here and look at our values, okay, so we're just using SOHCAHTOA. SOHCAHTOA. Just while we're here, I don't know why this has gone funny. Okay, so using SOHCAHTOA. So sine of 30. 30, opposite over hypotenuse, it's obviously going to be a half. Cos of 30 is adjacent over hypotenuse, root 3 on 2. And tan of 30, opposite over adjacent, 1 on root 3. Okay, so if I can draw that, I can draw all of these. I can do the same thing with 60. Opposite over hypotenuse. Whoops, root 3 on 2. Cos of 60, it's adjacent over hypotenuse, and tan of 60, it's root 3 over 1, or just root 3. Now you can see here we've got a square root on the bottom here, a third. Not too concerned about that. You could write it as root 3 on 3. Okay, but often you'll find that people recognise this a little bit more quickly than root 3 on 3. So it's sort of up to you, unless the question specifically says you need to rationalise the denominator. Same thing with our 1, 1, root 2 triangle over here. So sine 45, just opposite over hypotenuse. It's obviously going to be 1 on root 2. This is going to be 1 on root 2. And then tan is just 1 on 1, which is 1. Okay, same thing here with your third on the bottom. You can rationalise it with 2 on 2. Okay, so you'll find, depending on the textbook, some of them have rational denominators and some of them don't. So just flicking back quickly before we go on, about something about tan. Okay, we know that sine is opposite over hypotenuse, and we know that cos is adjacent over hypotenuse. So if I write sine over cos, that's opposite over hypotenuse, all over adjacent over hypotenuse, those are going to cancel out, and I'm going to get opposite over adjacent, which is tan. So this is one of our trig identities, is that sine theta on cos theta equals tan theta. And if you're wondering what's with the orange, this is a tangerine. Sorry, that's a joke. Okay, so we need to remember that. Now the reason that's important is because that can also help you remembering your exact values, because if you can work out what sine and cos of an angle is, can't remember tan for some reason, then you can use that ratio to work it out. So you've got two options here. You can either memorize these triangles and work them out that way. Eventually you will find that you remember these regardless of whether you memorize the triangles or not. Or you can use this table. Okay, so this is if you set up this table with your values 0, 30, 45, 60, and 90 across the top, and sine, cos, and tan down the side. Now, you know from your unit circle that sine of 0 is 0, because of course that's your y value. So we're over here, that's 0. Okay, cos of 0 is your x value, so that's going to be 1, and then tan is 0. And really all you need to do is memorize this first line, because if you remember that, so 0, half, 1 on root 2, root 3 on 2, and 1, then cos is the reverse of that. Okay, so 1, root 3 on 2, those are the same, half and 0. So you write it, if you remember that forwards, then that's that backwards. And then tan is just sine over cosine. So 0 divided by 1 is 0, a half divided by root 3 on 2 is 1 on root 3, and so on. Okay, so it's up to you. But whatever the case, you should be able to remember these exact values. You should be able to write them down with that reference to the table. If nothing else, it will save you time. Okay, and I don't think you get these on your formula sheet in an exam. So it's really good to have this sort of in your head. It's a little bit like times tables. Okay, so useful to memorize these exact values, okay, for 0, 30, 45, 60, and 90. Once you've got those, you can then do anything for your obtuse and reflex angles just by sort of adding these together. You can use the table or the two triangles. I personally prefer the two triangles, but it's up to you. So your triangles are your 1, 2, root 3. Okay, so if you draw that one, and that's your 60, that's your 30. Remembering 1 is opposite 30, 2 is always on the hypotenuse, root 3 is over here. Okay, or 1, 1, root 2, which is easy to remember because it's isosceles. 1, 1, root 2, there's 45 in here. Okay, so if you can remember those two, or you can remember the table. Remembering also that tan theta is sine theta over cosine theta. Okay, and if in doubt, rationalize the denominator. Like I said, it's a little bit sort of neither here nor there. If you're going on to study specialist mathematics, then we do tend to get a little bit picky about whether you rationalize them or not. If you're doing methods, then we'll usually give you the benefit of the doubt. But if in doubt and you've got time, then rationalize the denominator.